Hello friends, my name is Ravi Prakash Mishra. I am going to present my project which I did in this semester for pattern recognition course, which is sequence to sequence based artificially intelligent chatbot. I am going to present below slides like introduction, what did I motivate, how did I get my motivation, what are the basic building blocks of my model, and what is the actual sequence to sequence learning algorithm which I am using in this project, how I did the implementation in TensorFlow, what are some of the results which I got from this project, and I will then conclude with my findings, and I will also discuss about some of the future scope which can improve the projects. So first question which naturally comes to mind is, what is an artificially intelligent chatbot? So any software having a web UI or a smartphone app which answers to the questions posed by users is called AI based chatbot. So basically the user which is posing questions will not able to differentiate if the answers are being given by machine or by the human being. It is so realistic. Chatbot development is one of the subfield of natural language processing, which has got attention and in recent year because of the spurt in the growth of deep learning networks and the success of it in modeling the natural language processing tasks. When I first got to know about Apple Siri, when I used Google Hello, I was really amazed that how well they work and how realistic they answer to your questions. I did some of my research and I did Googling to find out how do they work, and I was really intrigued by their performance and their applications in the field. There are many applications of smart intelligent chatbot. For example, and companies can provide services to its customer without having a customer executive, just by using an app. Not only they can provide service, but it can be 24/7 service without actual any human error. There can be other applications as well in the field of banking, online reservation, and in the education, in the learning. There is one particular application which I was thinking that, suppose there are two persons who want to chat, but one of them knows German, another one knows just French. How do they communicate? Suppose there is a app which basically has this particular model and which translates the questions and the answers from different languages to different language. So there can be many applications which can solve day-to-day problem and also improve the quality of the services provided by different corporations. Now let's discuss about what basic building blocks which makes the model for this particular task. We will start from a network called recurrent neural network. This is like any other neural network with the distinction of having connection to itself. On the left side of the current slide, you can see a figure having an input of xt and an output which is being generated from this network called ht. It, apart from these input and output, it has a recurrent connection to itself. To understand it in an easy way, we can think of it as a unfolding network of in the time dimension. On the right side, you can see there are three building blocks of this recurrent neural network, one at each time step. In the middle of that, there is a neural network having input as xt, which is generating output ot. At this time step t, we get input from the previous time step, which was st minus 1 and was generated at that time t minus 1. This current time step t generates an output st, which is also which fed to next neural network at time step t plus 1. So how we have seen that how they are good at capturing the context. Now we transition from RNN to LSTM. RNN, despite having many wonderful capabilities, have some problems. For example, they are not very good with remembering the large context, which is typically the case with current problem in the NLP task. For example, in NLP task, our current word doesn't only depend on the word left and to right of it, but it can depend on the occurrence of the word which was, say, 5 time step back or the 5 time step after. So basically all the natural languages have these kind of dependencies, and RNNs are not very good with handling that. And also RNN have this problem of called vanishing gradient in the technical term. This is a difficulty found in training artificial neural networks with gradient based learning methods and backpropagation. In such methods, each of the neural networks weights are updated with the gradients which are calculated on the cost function with respect to the weight. Since all the activation functions are 10h and which has values in range of -1 to 1, their gradients also have values in that range. Now when these values get multiplied because of the chain rule from backwards to the front layers, this value gets smaller and smaller towards the front layers. That makes it really difficult to train the model as it gets towards the front layers. These kind of problems with the RNN leads to a special kind of RNN called long short-term memory model. Here it is more or less same with RNN but different type of inputs in its cell called logical cell or the memory cell. It has a different type of gates along with input, output, and the future gate. It has something called forget gate. All of these gates have enabling parameters which allows either whole of input to be passed or nothing to be passed or some partial amount of it to be passed to the network. So it has the activation between 0 to 1. Having 0 means nothing has to be passed to the network. Having 1 means all of it has to be passed, or anything between that means partial amount of input has to be passed. Now we move from LSTM to sequence learning. Now this algorithm has been taken from famous paper called sequence to sequence learning in neural network, which was published into 2014. This network has two parts in which we will discuss that model, but before that we see why we need this model in the first place. So various NLP problems will have sequences of the words coming in, which means they will be of not fixed size, as was the case with some of the problems we solved using RNNs. To solve this challenge of varying length, what we do, as you see in this figure, on the left side we have input of the words as A, B, C, and they are fed into a LSTM network which generates a fixed size vector W, and then this W vector is fed to an RNN network which generates the output, which is the sequence of words. So mathematically we can see that input sequence can be represented in the form of vectors from x1 through xt and the output as y1 through yt. By looping them over the equations mentioned in the figure, we get the output. The goal of the objective of the model is to maximize the probability p of having words y1 through yt given the words x1 through xt. So this sequence to sequence learning can be understood as encoder and decoder. In the encoder part, you see in this figure we have one sequence of words like "Are you free tomorrow?" Each word is fed to LSTM network, which generates a thought vector which is of fixed size. Then this vector is fed to the network of RNN, which generates a reply or a sequence of words. This is how question and answers are modeled. Now for the implementation side, I have trained my model on Cornell Movie Dialogue Corpus, which is a conversational exchange between different movie characters. It has basically two files. As you see on the right side, there is a screenshot on the top, which is the question and answers, their answers. So every pair will have first ID of the question, and the next one to that is the answer ID of that question. Now we look for these IDs in the file called movielines.txt. We will find the actual sentences mapped to that question or the answer ID. Now we've got the text of the question and answer. Now our task is to generate a numerical vectors from these texts. In order to do that, we apply a famous technique in natural language processing, that is first generating a dictionary of words and its frequencies from the whole text. Then for each question and answer, we replace the word with its frequency in the dictionary. That's how for each question and answer we get a numerical vector. Now about the model, we have in TensorFlow ready-made LSTM cells APIs, and then we have decoder and encoder defined in TensorFlow, which basically makes our sequence to sequence learning algorithm. Then I am using a ADAM optimizer, which is a momentum based optimizer basically, which not only see the current changes in the gradient but also remembers the last few changes in the previous time steps. Also, the other property of ADAM optimizer is that it changes the learning rate by its own. Then for the regularization, we use a technique called dropout, which has been immensely popular in many problems in a couple of years, and a cross entropy based cost function has been implemented in this particular model. For the training of the model, we did a training for around 100 epochs with a learning rate of 10 to the power minus 4, and the dropout rate has been initialized with a value of 0.5. A function named predict generates the indices of the most probable words. Then we use these indices to find out the actual words from the list of the words. Some of the results here, we see on the left side of our slide there is a figure which is boxing out some of the sentences. These sentences are output of the LSTM layer network in the encoder. We can see how LSTM captures the syntactic information between the text. All the clustered words or the sentences, you can see that how closely they are grouped together. Now you can see some of the question and answers on the right side. These are the answers generated. On the response of the questions which were posed to the chatbot. Some of the questions like my lady, this play will end badly, I will tell. The answer is let's go get out of here. Like this is not a date, so answer is no, what is it? She was fine to unknown voice, she is a good guy. So some of the answers are really good, which make a lot of sense and can be considered as the answer on par with the human answer. To conclude it, I have found out some of the things were very good with the model, like how good LSTMs are in capturing the long context, and we have also seen that model has been able to give some really excellent answers, and they are like really good and on par with human levels. To improve upon the projects, I suggest some of the changes which can be done to make model more versatile and realistic. We can train it on some other data sets like Twitter data set and actual conversations to improve the quality of the answers. Also, we can host this trained model in the cloud and expose the RESTful APIs so that any developer can use the trained model for their applications. Thank you everyone for your time.